So, let's kick off, right? So I think we'll just start with like a quick introduction. So I'm Karthik Tadinada. I am the founder and CEO of a company called Fortify Solutions. As you probably can tell from my accent, I'm British. And when I kind of talk about significant payments industry experience, so like Martyn and I worked together at a previous company where we build fraud systems for a whole bunch of interesting people. You cannot move money in the UK. If you spend money at any merchant in the UK, it touches one of the systems that we built or deployed on at least one of the legs. We built the fraud prevention system for the Australian debit card network, FPOS, a bunch of work for WorldPay here, and so that's been really fun. And I'm going to hand over to Martyn.
Yeah, so I'm Martyn Higson. So since then, I've moved on to a company called Dynamics, where we're doing synthetic data to test fraud controls. And that's kind of where this presentation around GenAI for red team testing payment fraud has come up. So.
The title of our talk is GenAI red team testing for payment fraud. Now, I can, for those of you who love buzzword bingo, like this ticks like, every row and every column, right? So I thought I'd probably spend a little bit of time talking about each of the doublets of words there. So, first GenAI, right? So I think a lot of people kind of think that GenAI is ChatGPT. You kind of like type text in and text come out. But what is super interesting is that you're kind of getting these models now. Are we? Oh yeah, there. So we're getting models now that are not just text, right? So they're like natively multimodal, so they can look at video and images and things like that. But even more interestingly, they are effectively, some of these are effectively Photoshop via text, right? So you can kind of give it an image and you can say, change this other thing, and it just changes it. And actually, the applications to fraud and things like that really come from those, right? So where you have really easy video generation, text editing, things like that. So the thing that's really important is all of this stuff has always existed, right? So I remember kind of looking at fraud rings where people made silicone masks and they kind of wore them to kind of trick. Sorry. Oh, amazing.
That's right. Right, so if I do play slideshow.
Oh, goodness me.
Can you just cut that applause for the end of our presentation? So,
okay. Yeah, absolutely. And so the thing that's really important is actually the ability to doctor images and things like that has always been there. You kind of had your resident Photoshop wizard, you had all of these kinds of things. But the thing that's really important is this stuff is now super easy, right? All you need is a text prompt, all you need is a text prompt, and that's fine. The other big thing that I really want to call out is how easy, so the AI boom is kind of bringing a lot of really powerful compute onto your laptops, right? So it used to be the case that no one really boasted about how many teraflops their neural processor had. But actually, because people are talking about large language models and GenAI, all of these capabilities, you no longer are reliant on ChatGPT to kind of run these services for you where they can control or have guardrails on what you're doing. So much power is coming to the local machines so that you can run very powerful images on MacBooks, right? So, and we'll kind of show maybe what's possible locally as well a little bit later. And then red teaming, I guess I'm at DEF CON. I'll probably spend 30 seconds on this slide. But really, it is about kind of adversarial testing to uncover how systems fail, right? So you actually have a bunch of good guys internally trying to find holes in your systems before the bad guys do, right? The core questions are, where are we vulnerable? What are the edge cases? What would a smart attacker try next? And then there are two kinds, right? So one of which is a black box, right? You know nothing about the insides of how systems work, and you're just trying like adversarial examples to see what comes out. And the other is white box, like where you have full visibility into what the rules are, how the system works, and you're really trying to discover edge cases, right? So without kind of like foreshadowing too much, a lot of image and video you can actually run black box testing on right now. Whereas like with transaction monitoring systems and things like that, like very often you're kind of like looking at more white box testing because the surface area is absolutely huge. And then, look, I think, I don't want to assume too much, right, about how, what people know about payment fraud prevention. But like any security system, it's a system of layered controls, right? So you have controls so that, you don't let, as the famous saying goes, on the internet, no one knows you're a dog, right? So you don't want people to kind of like sign up for your accounts without some sort of verification. So there are plenty of controls at account onboarding. So you're trying to keep bad actors out of your institution. There are money movement controls. So, so to say, okay, well, if there's unusual patterns of activity, you probably want to stop that flow of money and kind of look at that. And then the last bit is authentication, right? So like actually, we're unsure about what's happening, so we're going to step up, we're going to check you out before allowing you to go on your merry way, right? So of these, the first and the last, the account onboarding controls and the authentication controls are particularly vulnerable for two reasons, right? So actually, what's happened is that people don't go into bank branches anymore, right? Like actually, and if you make people go to bank branches, they tend to leave your bank. I haven't been to my bank in like over 5 years, and especially since COVID, I think this trend has really accelerated. So everyone wants everything to be digital. I want it now. I want it on my smartphone, things like that. And that's the first thing. The second thing is so much of like onboarding or authentication comes down to like analyzing images or images that you upload or video that you upload. And all of those things are now super vulnerable to like what large language models can do in terms of changing those things, right? So I think why now? Okay. So I was about to, so I think we've kind of like done the, slide the wrong way around. But global fraud losses were $500 billion, right, last year, which is like an absolutely incredible amount of money. I do have another, a related question. So in the UK, obviously the defense budget in any country is absolutely huge. So I think they spend about $70 billion on defense. What percentage of the defense budget do you think got spent on defending against fraud? 5%? Bit higher than that? 10, 12? Actually, in the UK, banks spend about 70%. They spend about $50 billion across, right, like fraud and AML or things like that. So this is a significant problem. Banks recognize it's a significant problem. There's a whole bunch of investment that's gone into it, but there's a tidal wave of change about to come that, I think people are not aware. So Sam Altman kind of really helped us out a lot by kind of saying, hey, I'm very nervous that we have an impending and significant impending fraud crisis because of what his models, surprisingly enough, now enable people to do. So like 20x increase in deepfake fraud. So fraud volumes in the US up 4 times in 4 years.
And so that discrepancy between the right-hand number and the left-hand is reported versus the assumed size of the problem when you consider all of the like unreported sort of fraud as well.
All right. So here we go. So that's the background done. So what we want to do is to kind of show you a few examples of what is possible right now, right? So actually, Martyn is a technical whiz. He's going to show you like a lot of these things, but I want to set the scene, right? So document verification is very often the first step that banks verify, right? So they kind of say, hey, can you send me a utility bill? Can you send me like your driver's license? Let's kind of like go verify that these things are right. And then like that's the first step of verification before we open an account for you, right? So over to you, Martyn.
Cool, thanks, Karthik. So authenticating customers is like critical to banks. So making sure you know your customers are who they say they are. And when people don't want to go into a branch anymore, all of that has to be done by information you provide remotely. That's documents, photo IDs, and now kind of selfies and liveness checks. And like we said just before, generative AI is making all of these kind of approaches vulnerable. So I'm going to show like some examples here, and none of these examples have been a huge investment of time. They're kind of very lightweight examples to make it kind of approachable. They're all using readily accessible tools. I have not built any code. I have not written any tools myself. The most complex thing we've done is train a detection model to try and catch out our fake things better than things we can get off the shelf. So if we start off with bills and documents, I had really high hopes that using ChatGPT, I would hit some guardrails when I said, oh, I found this gas bill online. Can you address it to someone else? I was like, come on, ChatGPT, tell me you can't do that. And with Mr. Fake Person, it throws up kind of a pretty much genuine looking bill that you'd have to kind of look at quite closely. I was like, maybe the guardrails only come in when you put a real name and a real address. Maybe there's something to protect humanity kind of built in there. No. And I think kind of what this third image actually shows, because this was at the end of like the chain, there are a couple of bigger tells that it's fake. So there's some mistakes that have cropped in when it's done kind of like an image generation of an image generation. So there's like some pieces of text that don't quite read right, but fundamentally like these kind of things are, you can thread that with ChatGPT Web very quickly now.
Just very quickly, right? So actually, I'm really curious, right? So has anyone spotted, like, the tell? So you, sir?
Like the bottom line, the wording is a little bit awkward.
Yeah, this one?
Yes.
Yeah. And actually, so those of you with very sharp eyes, I don't know whether we're standing in the way.
Very sharp eyes not blocked by the podium.
Yeah, not
blocked.
Okay. Sorry. You will see that actually, the address is done perfectly well. But towards the end, you will see that the bill FAQs is blue when the original is actually in black, right? So it kind of got confused about the color above. And the bill FAQ at the bottom has turned blue for some reason. It just kind of bled the color down. But apart from that, you've got to be looking so closely to kind of catch this.
I think that this is the biggest, or one of the biggest gas companies in the UK. So I think if you've got like a smaller utility company, the people who are looking at documents and the systems looking at it won't have as many positive examples. So I would hope that a system will detect this because they will have hundreds of examples of a British gas bill. It was just the easiest one to find an example I could work from off Google. And then kind of the next thing we started looking at was, okay, what about sort of swapping the images on ID documents? Surely ChatGPT won't do that for us. It turns out it does, but actually it does quite a poor job. So what we did instead, we found a repo online called Deep Live Cam that allows you to do either live video swapping or to swap images. And so we took the DVLA sample license. This is just one you can pull off the government website in the UK to show you what a driving license should look like, and a wonderful picture of Elon Musk. We kind of run it through the model, and we can map Elon's features into this. And we're like, okay, well, it's not really fantastic. So then we use an upscaler to kind of make it a higher resolution image. And then kind of to test this one, I was like, okay, well, where can I start looking for things? And so there's a lot of companies that are selling services to academia at the moment to detect people who are using AI in sort of university and college studies. So I'm not going to name the provider I found, but I basically put this online onto one of their kind of sort of tests, and it said it is a 0.22% chance of being AI. So this is a model you could pay money to use that says this license looks legit.
We would suggest you not. Yeah.
So Detection models, I guess kind of with generative AI, there's like hundreds of models that are generating different images. The detection is always several steps behind. And so we started looking at a lot of academic papers, and you get models that come out and they've got like a really good detection, like they have like a 90-odd%, 99% detection on their training set. And then you apply them to a different benchmark and it plummets down significantly. And so what we found is that a lot of models, when you try and generalize them, are getting like an AUC of about 0.58. And for anyone who's not a data scientist, AUC of like 0.5 is like a coin toss decision. So it's not doing significantly better than random choice at detecting deepfakes. So we took one of these models that's available called Capsule. We trained it on a data set that included a lot of the deepfakes we were making to try and get that rate up. Probably not massively easy to read up here. We've kind of got it up to sort of about 91% accuracy. So we're like, okay, this is doing a lot better than the stuff we took off the shelf. So we took a picture of my face mapped onto Elon, and 0 for the class here is kind of saying it's thinking it's genuine. So the initial model we took off the shelf said it was genuine with like a 30% confidence, and then even with our retrained one, it still couldn't detect that was like a fake image. So
just one question. So the other thing to kind of say about models like this, right? So you kind of think, well, 90% accuracy is really good, right? But when images are this easy to generate, actually fraudsters are willing to try 100 images to kind of create 10, right? Because like actually for them it costs very little. They're just gonna try, and so the thing then becomes actually the economics of like the people kind of like generating these things versus like what you can detect and deal with. Kind of like the equation really tilts, right? So I think most people will be like, hey, I made a model with 90% accuracy, but actually that 10% is still big enough for fraudsters to kind of really have a go at like bank systems, right? So I think, that's something important to kind of say.
So yeah, so those previous examples were around static things. Static things are much easier, I think, to kind of manipulate than moving things and kind of real-time images. So kind of the next place to start looking is like liveness verifications. This is where a bank is saying, okay, now you've taken a photo of your ID. Can you open the camera? Can you look left? Can you look right? And then trying to get kind of more confidence that it is actually you, or the person that has the ID is the person who's able to kind of prove that they're there at that time as well. And I guess kind of the other one that wasn't initially part of this presentation until Sal Altman said some banks are still using voice recognition is that we thought we'd give voice a go. So is this one going to work? So we've got 2 recordings. One of them is genuine and one of them is fake.
So actually, maybe it's just worth kind of saying a little bit about these genuine and fake things, right? So actually, what was really interesting is this is like a commercially available API, 11 labs, right? Like we have that at the end of our talk. And what you can do is you can upload so they suggest 2 hours of video. We had, it was like, 2 hours is too much. Martyn uploaded 7 minutes.
Yeah, so I read a newspaper article, uploaded it, told me it wasn't enough data, so I read another one, uploaded it until I crossed the absolute minimum threshold to train a model. So this is kind of like the worst quality that it can do. And this is like a publicly available thing that people use to record audiobooks once they've already recorded some audiobooks and they don't want to read like the next one in the series. So here is sample 1. And these aren't going to work, are they? Right, these.
I'm Martyn, and if you know me, you'll know this voice. But are you sure this is really me?
There's your first sample, and then where's the slides gone? Lost the slides. Then we have our second one.
I'm Martyn, and if you know me, you'll know this voice. But are you sure this is really me?
So how many think that number 1 was Martyn's real voice? Okay. How many think it was number 2? Okay. Even split, right? Martyn, which one was real?
No, number 1 was the real one. Yeah, number 2 is the one that was trained off a 7-minute sample of like unrelated kind of audio clips. And I think I can tell the difference quite easily, but I think I spend a lot of time with myself. But I think kind of my bank probably doesn't spend that much time with me. I can probably count the number of times I've been on the phone to the bank in like one hand in the last 5 years. So I think they won't have a good sample of my voice either. So yeah, Sam Altman said voice is already cracked. And I think that is kind of like pretty clear that it is very easy to kind of create synthetic voices that are able to pass. So then the next piece, so kind of then we start looking at some of the live face stuff. So I'm going to try and do a demo here. Demos always go badly, right? So let's see how this one goes. So this is Deep Live Cam, the kind of repo that we were talking about earlier that's like an open source code. So there we go. So they've made this pretty customer friendly. So you basically can select a face that you want to try and map yourself onto. You can select...
That is Sir Keir Starmer, the British Prime Minister. So yeah.
So we can then tell it that it needs to put my face as the other side, and we can hit live, and we'll see what it does.
So by the way, like actually this model, by the way, is, oh, sorry.
So actually it's detected me on the screen as different to me here. So I think what I've not done here is tell it there's actually many faces. And now you can see that it's kind of like changed a lot of the characteristics of my face. And this model is not a new model. This model is several years old. It's a 128 pixel replica that it does. There's kind of people in academia trying to make much higher resolution changes now. But yeah, these are like super accessible. And so if you can manipulate the photo ID, you can change these things kind of with the liveness. As technology advances, this will only get sort of more advanced and more easy to kind of fool defenses. So I'm going to stop this because it feels really creepy.
I think just a couple more points on that, right? So I think one of the things that's really important about those face swapper things is that particularly when you're kind of relying on verification over over the internet, a lot of detail gets taken away in the compression anyway, right? So if you're on a Zoom call, things like that. So a lot of the signals that are really useful to kind of like detect that this is not the person kind of like go away really, like once you're on a Zoom call. The other thing as well that's kind of really interesting about this is like a lot of the high quality silicone masks that kind of like people used to do that. What they did was they kind of changed how the skin works, right? Like actually like there's a lot of like black arts in kind of like detecting when skin is really live, and they kind of like rely on looking at like blood flow, right? Like actually when people go like when things go in and out. But when you have a model like this that's kind of like transforming your face in real time, if your face expands a little bit, guess what? Like the pixels expand with that too, and then come back down. So there's a whole bunch of new tricks that I'm sure that like a whole bunch of really clever people are kind of like working on to kind of like detect this. But I mean, that model is like 4 or 5 years old, right? And actually, literally, we did like zero training. We just downloaded it off the internet, and it's actually surprising. So, and on Windows machines, actually, it uses the GPU. So you get much higher quality. You can add an upscaling example. So for our sins in using a Mac, you kind of get 4 FPS. But on a Windows machine, you get 25, 30 FPS. And you can pipe that straight through to be a virtual camera and kind of like appear to be whoever you want on any Google Meet or Zoom call.
Yeah, exactly. And like then you can push that through to like an emulator of an Android or an iPhone if you're trying to use those kind of apps. So I think kind of this means that the future is like really tricky because it's getting harder and harder for you to check that somebody is who they say they are remotely. and technology is moving super fast. I think kind of the default is to come up with new technologies that are sort of super secure and harder to use. But we have a lot of people out in society who are non-technical, who don't want to have to do like super complex authentication. So I think what we really need is banks to kind of invest in testing a lot of these controls against this, trying to strengthen the controls, but keeping an eye on like their customer base and kind of making sure that they're coming up with controls that their customers are able to kind of use with like minimal friction. Because the best case is friction means that banks lose customers. The worst case is like people get excluded from like the banking system. So yeah, I think this is kind of a really key area that everyone kind of needs to start sort of paying attention to. And then I think now we're going to move on to payments.
Yeah, so I think that covers the piece where you can kind of like black box test, right? So you can kind of do utility bills, images, liveness, all of that kind of stuff. But actually the backstop behind all of these is a set of money movement controls that every bank has, right? So these will be things like, okay, well, I don't want to allow, well, if someone does like, more than $10,000, right, above their usual baseline, then kind of create an alert, like a whole bunch of these things. And the really hard part about, and actually money movement controls are very similar to network controls, right? So effectively, if you have firewall controls that say, allow this traffic, deny that traffic, things like that, like you can kind of think of them very similarly. And actually, the thing that I kind of really want to call out is that just like a firewall control or like a payment control, the diversity of legitimate use cases is absolutely huge. People do crazy stuff all the time. And if you've ever been responsible for network control, or if you've ever been responsible for payment system, you're like, oh, this is fraud every day. And it turns out that people had very, very legitimate like use cases to kind of spend money that way. And so what is really interesting is like banks have to kind of like tread this line between, like actually good customer experience, allowing people to spend the money that they earned however they choose, and actually not being rinsed by fraud, right? So to kind of like leave gaps. And the thing that's really hard about payments is people spend money like in several different ways, right? So you can spend money on an Apple Pay or a Google Pay. You can spend money online. You can like use a chip and dip. You can use a chip and sig. You can use a magstrap. You can use a whole bunch of things. And you can spend money in different countries. There's a whole bunch of things that like people use. And it's almost impossible to kind of write good controls across this entire surface. So what fraudsters do is they kind of like test the gaps, right? Like in all of these controls to find something that they can scalably monetize, right? So what we think is, like with money movement controls, we kind of really feel that they're best tested as white boxes, right? So to kind of say, okay, well, let me map my attack surface. Let me look at the rules that we have, and how can we identify gaps, right? Or actually, if we have found a gap, how can we figure out like whether this is a scalable gap or whether like it's a one-off or something like that? And these gaps constantly keep coming up because companies launch new products, there's new regulation, like there's all of these kinds of things. So anytime there's a change in the system, there's always something that gets missed out, right? You can't like lock down everything and be perfect. And so I think, anyone who's kind of been in payments for a little while, like actually the moment of greatest risk is the first 2-3 months when you've like kind of launched a new product, and then you're kind of like really crossing your fingers and hoping you've done your homework properly, right? So then, the other thing as well that's really unhelpful is that rules and like the payment system rules are very often in proprietary languages, right? Like actually, if you have an Actimize, it has its own language, FICO has its own language, things like that. And these systems kind of sit at the intersection of like deep domain knowledge of what fraud is, but also deep domain knowledge of how to program well. And so that intersection is kind of rare to find the gaps, to kind of find people that cover both. And so you either end up with gaps in terms of understanding payments, or you end up with gaps in like the quality of the rule that gets written, right? Like actually, programming is the art of handling edge cases really well. And so if you kind of, you know fraud, but you don't know all the edge cases that appear in payments, then you kind of like end up with all kinds of crazy things. And then again, right, like internal teams are bottlenecked by like external timelines, lack of skills, the same problems that occur in like cybersecurity systems too. And so again, right, like actually because there's so much knowledge that kind of goes into creating a good payment systems, payment monitoring system, right? Like you kind of like need knowledge of fraud, you need knowledge of your attack surface, you need good programming. And actually, you have it's very tricky to measure like, code coverage kind of like metrics, right? To kind of say of all of the ways people can spend money, how many are covered, right? Like, do I really have a control against that? Are these sensible? Things like that. The other thing as well is that the output of like a analytic system is very often alerts, right? That someone has to go work. So people are very happy when you have low alert volume. They're like, oh, it's great, right? I can have a bit of a break from like constantly working alerts like every 30 seconds, every 3 minutes. And there's a great example of a Spanish bank that I kind of know of that lost $400,000 in like 3 days. Because their single most important rule had like a change in the data that was kind of like going into it, which means that system, that one rule didn't alert. So the volume of alerts went down like 10%, but actually it just meant that they let through for 3 days $400,000 worth of fraud, just 3 days, right? So I think the tricky thing is because these are such complex systems, identifying and isolating failures in like one specific thing is very tricky to do, right? So, and then infrequent alerts can hide like data or logic issues. And again, right, misconfigured rules or missing data or changes in all of these things results in, actually sometimes it's like misfraud, sometimes it's like block genuine customers. So what we want to do is to kind of like talk about like what some controls might look like and how large language models might help us to kind of like gain more confidence that these systems are doing what they should be doing. Right? So over to you, Martyn.
Cool, thanks, Karthik. So here, like this is like a very small sample of rules that shows like a couple of different things we see. Kind of, I guess this one's looking mostly as what would be a card issuer. So you've got this whole set of things that like you've got some behavioral things, you've got some kind of account limit rules. We've also see sometimes you get rules that are like blacklisting rules that are kind of very specific. So like one person we're talking to, they had an attack, don't worry, we've written a rule to patch it. And the rule that they'd written to patch it just blocked that specific user's postcode from transacting. So if somebody else came along and acted in the same way, they'd get through the controls. And I think this is kind of, everyone's being reactive, everyone's building controls to like stick the tape on the next thing that's going to sink the boat. So yeah, this here is just kind of like a very small example grid of some of the rules you might have. You might have different rules for new customers, different rules for established customers. You might be limiting things on merchants, account values, and then kind of like MCCs as well, so merchant categories. So it's quite common to block crypto and gift cards and gambling in a lot of card places. So one of the ways you could look at AI to kind of help with testing is to take a rule. So we take the $5,000 in 24 hours rule, and then kind of take the way that rule has been coded in the system. So here I've written it in kind of like pseudocode so that it doesn't give away a vendor system. And then kind of what we can do is take this, where did the terminal go? And close that one off. So we can go for the so here we're basically, this is kind of a simplified thing, so I'm going to run this locally rather than kind of trying to rely on the internet connection, but we've got kind of a description of a rule, kind of the implementation of the rule, and then we've asked it to kind of suggest like how might this rule be exploitable. So this is here right now is like a single example. So kind of what we're going to do here is run this into kind of Llama, a DeepSeek model we've got offline. I think this is probably going to be small because it's probably uncached it while we're here. So I ran one just before we came on the stage that I can stick up here. So kind of here we've put that exact same rule in. We're like, okay, well, where are the gaps in it? And I think kind of one of the big things that rule had, if we remember going back to it, was it's essentially, so I'm going to echo the prompt as well.
Cool.
Yeah. Never try and type live. It's not in this shell, it's in the other shell. So basically the rule was truncating the date, and it was saying, okay, we're going to bucket it in what is the date on this transaction. So one of the things the LLM has kind of told us here is, well, this isn't going to catch you on a midnight barrier, and actually what you would want is quite clearly like a rolling window so somebody can't exploit midnight. So it's given us some piece of insight there, some ways to test it. There's also some pieces around time zones in the system. So, I mean, it's given us a shot. When you run this on a more powerful model, you get a larger set of different cases. You can obviously like run it with RAG and stuff to kind of get more sophisticated things. But fundamentally what we've had is a rule that's been analyzed, and we've kind of been able to check whether the logic matches up to kind of the intention of the rule. So then we find. So then the other way that we've been looking at this is kind of, well, what if I've got an exploit that I'm aware of, and I've maybe written some rules to try and protect me against this, and what I want to do is test whether I've prevented behavior in the system rather than the example that hit me. So kind of where can we add some fuzziness and some variance to kind of the example we have to make sure we've got a bit more confidence in the testing that's been done. So kind of here we have
Martyn, just put that back up again, and actually maybe we can just talk through what that example looks like. There's a lot of data on there, but I think it's just worth kind of like going through what the fraud example is here, right? So, I mean, I'm not expecting anyone here to know the distance between Manchester and London, right? Like, but actually they're like 200 miles apart. And if anyone knows anything about the British transport system, to kind of like make even 10 miles in 2 hours is a pretty amazing thing. So what we have here is like the first transaction is at a grocery store in Manchester, and the second transaction is at an electronics store in London, right? And both of them are physical transactions. So actually what's happening here is that like this person has traveled well, actually, maybe not fast. I mean, sometimes you see faster than the speed of light kind of things, but like actually has traveled certainly far faster than the British transport system allows, right? So I think so that's the exploit. But what is really interesting is that very often teams will kind of like try and manage this by either blocking, like so if their customer base is mainly in Manchester, they'll say, hey, like actually let me block like high value transactions in London because this is a high risk country or whatever, or high risk city or whatever it is. So what that then leaves you vulnerable to is actually having two different tests, right? So maybe Edinburgh and maybe somewhere else, right? Where the pattern, the fraud pattern really here is that actually people are traveling unreasonable distances rather than the fact that it was London or Manchester, right? So like actually, and so very often when you're kind of like a fraud team under pressure, you do the simplest possible thing. You say, let me block London, or let me kind of block electronics in London, or whatever it is. But actually, large language models allow you to look at the pattern and give you help in kind of like trying to extract what the pattern you really should be blocking is, right? So.
Cool, thanks, Karthik. So then we can take this similarly to what we did before, and we basically provide that data example. We're like, okay, could you give me some more examples of this fraud attack vector? And just give me some more data to work with. So that, again, what we would do when we're doing this in like kind of more of the red teaming stuff is we're using sort of RAG and kind of more complex models. But if we feed this one into DeepSeek as well, we can see whether it's now cached and it's going to run quickly. But basically, it's going to try and identify what the pattern is within that data and then try and create another set of transactions to kind of go with it. It's taking its time. So what I'm going to do is just open up.
There's an R at the front.
So kind of here we asked it to create some more examples. And again, it's not the best model in the world here. So we've got some of these kind of big travel distances. It's kind of done some things here. So in that last example, we had some very high value transactions that probably give the game away a little bit, that someone's suddenly going and spending like $1,200 on like electronics in another city. So here it's kind of taken away the high value transactions. So maybe the rules have been targeted towards that. Here we have much less geographic distribution in the second scenario. So it'd be interesting to see kind of how that one's kind of panned out. And then some international stuff comes in. So what it's doing is just changing a couple of parameters here and there to kind of see, okay, well, here's a more diverse data set to kind of use to kind of see whether you've covered the gaps. And so these kind of examples we've covered have basically been very, very simple examples of like single rule or maybe the single exploit. One of the problems with kind of fraud systems for anyone who's worked with them is because they're all being patched reactively. So you create a set of rules when you're new, you think those rules are going to cover your program, you then get hit by a fraud attack. So you go and build another piece of analytics to go and sort of prevent those examples. And what you end up with is this very patchwork kind of mesh of rules that they're not really designed. A lot of it is kind of like very organic, very reactive. And so it's very difficult to look at a set of rules. We're talking maybe like 100, 200, 300 plus, like these are very large rule sets, quite difficult to kind of process, like where are the actual potential gaps. So with GenAI and kind of some of the bigger models, we can provide sets of analytics rather than individual rules and kind of have it identify where does it think, within the space of payments, there might be sort of gaps that aren't covered in this set. So kind of the thing we're looking at with some of the red teaming is that sort of turning this individual analysis to run it at very large scale across like a full sort of set of fraud rules.
No, and that's it. So I think that's all we have to show. But I think, just to kind of like summarize really, I think if you kind of are relying on the authenticity of images or video, that's something that actually we should be really careful about, because GenAI makes editing images and editing video or generating video super simple and super accessible. I mean, I'm sure that like a lot of you have heard about like these North Korean IT workers that kind of like show up and kind of interview really well. And again, the thing that's really amazing to me is that with increasing use of cryptography and like all of these kind of things, the softest target in any system is now the human, right? So actually people are kind of really targeting the contact center workers, like, your customer service representatives, and they're under pressure, right? So to kind of like, make customers happy and like all of those kind of things. So it just needs to be convincing enough to convince someone who's busy, under pressure, doesn't have a huge amount of time to kind of like, to kind of like break through. And then the next slide. And then, actually, yeah, so then this is like all of the services we use to pull these demos together, right? So ChatGPT image, there's a local thing called QN image that you can just download and run. The face swap is like Deep Live Cam, it's like a GitHub repo. Audio was Levin Labs, right? Like you can like sign up there, and scenario generation, pick your favorite LLM, right? Like all of those are pretty good. And I think that's all, folks, right? So if you have any questions, we're happy to take them. But yeah, straight away.
Definition of a fake image.
Something that is, like not a real person, right? Like, or actually modified or doctored in some way. Yeah.
Like the original image would be that you take a photo of yourself and you put it on the internet, and then the fake image would be altering that photo.
Yeah.
So yeah, so I think that that's like the fake image would be if you've altered the image itself. I guess kind of when you're making fake variants of documents, that'd be like that. You might not edit the image itself, but you might be inserting a different image within it. So kind of anywhere where the output is kind of non-representative of the input, I think.
The Birmingham transaction was also squared off. Yeah. You?
Yeah. Okay. So, the questions I have is, does your LLM take into consideration, like, if on somebody else you use for banking. For example, they track reservations. So if you are traveling,
Yeah.
they sense that
Yeah.
hey, you are in like Canada.
Yeah.
Is that a consideration?
So that is something we can bring in. So I guess that's basically up to the bank today. It's kind of 100% assessment. So what you see in like the more sophisticated banks is that they're tracking individual behaviors and not the kind of hard verticals like the country large government. So I guess what you would generally expect is if it's somebody who never travels, you probably do want to err on side of caution and stop those transactions because it's like somebody who's like has been defrauded. Whereas if it's somebody who's like regularly traveling, then you give them a lot more like leeway to travel internationally. And I guess maybe you can also limit what kinds of transactions they can do when they arrive in a new country before they kind of do a chip transaction. Then we know you've actually got the card. And
I think the key thing is that actually, if you're just relying on one thing, like that's vulnerable. So if you're kind of pulling images plus location plus other things, those are much harder, right? So again, it's the same good set of security principles. Use as much data as you have, like all of that kind of thing, right? So. Oh yeah, so I think we're going to stop here, but we'll be around for the next few minutes to kind of like take questions. But like, thank you so much for showing up. Oh, goodness me.
Can you just cut that applause for the end of our presentation? So, okay.